Hello, I'm Patty Simpson with Simpson Math. In previous videos, we learned to graph 7 different parent functions. In this video, we're going to learn about vertical transformations of those functions. So first, let's remind ourselves about the absolute value function, that V shape of all those functions. And this was the parent of our absolute value functions. And we graphed these 5 points on that function. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Now, what we're going to do now is we're going to create a new absolute value function where we take our parent, the absolute value of x, and I'm just going to add a value to it. Say we add 4 to that value, to that function. And let's just see what happens when we add a value to our function. So let's make a t-chart to help us to graph it. And I'm going to start with those same 5 numbers that I did before, x values that we did last time, where I'm going to plug in -2 for x, or substitute in -2 for x. And when I do that, the absolute value of -2 plus 4, well, the absolute value of -2 is 2, because remember the absolute value is just the distance from 0, and -2 is 2 units from 0. So that's 2 plus 4, which equals 6. So that tells me there's going to be a point on this function at -2, 6. Now I'm going to substitute in -1 for x. I'm going to evaluate this function where x is equal to -1. And the absolute value of -1 is just 1. So 1 plus 4 is 5. There's a point on this graph at 1, 5. Let me go ahead and graph those here so far. So we've got -2, 6, -1, 5. Now if I put in 0 for x, well, the absolute value of 0 plus 4 is just 4. If I put in 1 for x, well, the absolute value of 1 is 1, so 1 plus 4 gives me 5. So at 0, 4, there's a point. At 1, 5, there's a point. And if I put in 2, well, then the absolute value of 2 is 2, and 2 plus 4 is 6. So there's another point on this graph, this new function we've created at 2, 6. So this new function, where we just added 4 to our parent, notice what happened. It just shifted up 4 units. Because our y values, we just added 4 to each one of those y values that we had before. And our y values are here on a vertical axis, so it caused it to vertically shift up 4 spots or 4 units to get this new function. And it turns out that every time we add or subtract a number from our parent function, that all that's going to happen is it's just going to vertically shift that function up or down, whatever number that we add or subtract to it. So there's our vertical shift of this new function. Now, when you do it at home, I want you to vertically shift it and then go ahead and label those points for me so that your reader can see right where the points are. Just make it, it's kind of like in writing when you put a capital letter or period. Here in math, we need to either label our axis or we need to label our points to let our readers know just what our scale is in our graph. I'm going to do the same thing here with this cubed root function. So here we have a cubed root function. Remember that that's it's like our 3rd Street here in Temple sideways. It's on the side, so it goes sideways. And we learned with the parent functions to graph these 5 points, -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. And I'm going to create a new function just by taking that parent function, and I'm just going to subtract 1 from that parent function. And what we learned earlier is what should happen is it should just take our graph and shift it down 1 unit. It should just take this whole picture, this whole graph, and shift it down 1 unit. Now I'm going to show you algebraically how we can do that, so that in the future when we're looking at multiple operations, we can just kind of do some algebraic operations there to help us to be able to graph it. So here we know what's going to happen. It's going to shift down 1 unit. And that shift is a vertical shift, so it's affecting our y values. So I'm going to leave my x values alone, and I'm just going to subtract 1 from each one of my y values, so that I end up at -8, -3, -1, -2, 0, -1, 1 minus 1 is 0, and 2 minus 1 is 1. So I now have 5 new points for this new function that we've created. And those 5 points are at -8, -3, -1, -2, 0, -1, 1, 0, and 8, 1. I'm going to connect those to make the shape of the cubed root function. I'm going to go ahead and label those points so my reader knows what my scale is here on my graph. And notice what happened to my function. It just shifted this function down 1 unit. So whenever we take our parent function and we add or we subtract a value from it, it's going to affect those y values, and it's just going to move our function up or down. And we can do that algebraically just by adding or subtracting that number from our y value from our parent function. Now let's look and see what happens if we multiply our function by a value. So I'm going to create a whole new function here. Instead of adding a value to our function, I'm now going to, let's call him g of x, I'm now just going to multiply that function. So there's my parent, and I'm just going to take that parent and multiply it by a value. And let's see what happens. So again, if I put in -2 into my function, well, the absolute value of -2 is still 2. So we have 2 times 2, which equals 4. If I put in -1, well, the absolute value of -1 is equal to 1, and 2 times 1 is 2. So there's going to be a point on this new function at -1, 2. If I put in 0, the absolute value of 0 is 0, and anything times 0 is 0. So 2 times 0 there is 0. So there's a point on that graph at 0, 0. On this function, if I put in just +1, well, the absolute value of 1 is 1 times 2 is also 2. And if I put in 2 into the function, then the absolute value of 2 is 2. 2 times 2 then is 4. So there's a point on that new function at 2, 4. Let's graph those points. So I have -2, 4, -2, 4, -1, 2, 0, 0, 1, 2, and 2, 4 are the new points on this new function. Notice it still has the shape of its family member, but what happened is it stretched that function vertically. It took all our y values and it doubled it. It just stretched our function there vertically. And it turns out that every time we multiply by a value, we multiply our function by a value, it's going to stretch that function or shrink that function. So we're going to have some sort of vertical dilation there. So I'm going to do the same thing here. I'm going to create a new function, and this time I'm going to take and I'm going to multiply the function by 1/2. So let's create a new function so that I have 1/2 times the cubed root of x. And again, we know that this is going to affect my y values. I'm just taking whatever my function was and multiplying it by 1/2. So whatever my y values would have been, I'm going to multiply them all by 1/2. So algebraically, it looks something like this. I'm just going to take my y values and multiply them all by 1/2. So that the new points, the points on my new function are going to be at -8, -1, -1, -1/2, 0, 0, 1, 1/2, and 8, 1. So I just took all my y values and multiplied them by 1/2, the y values of the parent function, and I multiplied them all by 1/2. Now I'm going to graph those, and we're going to notice that our function is going to shrink vertically. It's going to affect us vertically. So that we have a point at -8, -1, -1, -1/2, 0, 0, 1, 1/2, and 8, 1. So that our cubed root function looks something like this. -1, -1/2, 0, 0, 1, 1/2, and at 8, 1. Those are the points on our new function. So anytime we multiply our function by a number, it's just going to vertically stretch or shrink our function. And we can take our parent function, the points from our parent function, and just multiply our y values by whatever value is being multiplied by the function to get our new points. Then there's one last transformation that we can do, and it's called a reflection. So in that case, what we are going to do is we're going to multiply our function, this time by a -1. I'm just going to take that function and multiply it by a -1. And let's just see what happens when I multiply it by a -1. Well, if I put in -2, the absolute value of -2 is 2, but then it's a negative of that -2. So let me write it out just to make sure. So here, the absolute value of -2 is a +2, but this negative out here, this -1 is being multiplied times the function, so it ends up with a negative out front. So we're going to have a point on our new graph at -2, -2. Then, if I put in -1, the absolute value of -1 is 1, but this negative out front that's being multiplied, -1 times that 1, gives me a -1. So I have a point at -1, -1. If I put in 0, the absolute value of 0 is 0. A -0 is still just 0. If I put in 1, I'm going to get out 1, but then this negative stays out front. And if I put in 2, the absolute value of 2 is 2, but that negative then stays out front. So I have these 5 points on this new function. And notice what happened to our parent is it just took it and it flipped it vertically. It reflected it over this x-axis. So when we multiply our parent functions by a negative, it just takes and reflects it over the x-axis. Let's do the same thing to our cubed root function here. Let me just label my points. Be sure on your graphs to label your points or to label your axis so your reader can read to see what your scale is. I'm going to do the same thing here, only this time I'm going to do it algebraically. So when my function is being multiplied by a negative on the outside here, this negative times the function, it's going to affect those y values. And so I'm just going to take all my y's and multiply them by a -1. So I have a +2, a +1, a 0, -1, and -2. And so my new points on this new graph, we know what's going to happen. It should reflect it. In other words, this should come down there and this should go up there. Should reflect it over this x-axis. But let's just see if it really does, doing it this algebraic way, where I've got -8, 2 is a point, -8, 2, -1, 1, -1, 1, 0, 0, 1, -1, and 8, -2. Notice that it really did just reflect my original function. My parent function was just reflected over that x-axis. And we can test to make sure that this is actually working. Let's put in a -8 just to check ourselves. So if I put in a -8 for x, if I evaluate the function there at -8, well, the cubed root of -8 is a -2. And then I'm multiplying by this negative out front, so I have a negative of a -2 does give me a +2. So I can kind of check myself just to make sure. But I can just take my original parent function and multiply all my y values by -1, because every time it's affecting those y values, it's a vertical reflection. So there are 3 different types of transformations there that we looked at. We looked at vertical shift, where we add or subtract a value, and it just takes our parent function and moves it up or down, however many values there are. When we multiply, it's going to stretch or shrink it based upon that number. And so we just multiply our function, our y values, by that, scalar. And then when we multiply by a negative, then it's going to reflect it vertically over that x-axis. We're going to look at multiple operations of transformations in the next video. Thanks for watching.